Hello everybody, I'm Nick, and in this video you're going to see 100 of my top C# and .NET tips for .NET developers, aiming to help you catch up with new features, maybe old ones you didn't know, and ultimately write better C# code. Now that is the second video in the series. I already have one of those with the first 100. These are the second 100 coming from my YouTube shorts, but if you're not watching shorts content, I think it's worth seeing those features because they will really help you write better code. And on the subject of something that will help you write better code, we just released a completely free course on Dometrain called Hands-On Learn Postgres. 17 hours worth of content, and all of them are practical exercises. So you come here, enroll for free, and you start interacting with the IDE, with a real database running on your browser, so you can see the table data and then write an appropriate query for your test to pass and progress to more than 170 lessons. Really exciting, really cool. I really want to know your thoughts, so give it a go. Let me know what you think about this more interactive experience. And now back to the video.
101. Deconstructing a tuple or an object but only need one value, you don't have to name everything. The underscore is called a discard, and it tells the compiler, I don't care about this value. It works with tuples, records, and even your own deconstructible types. It makes code more readable, reduces noise, and avoids compiler warnings for unused variables. You can also have multiple discards in one deconstruction. They're treated independently. 102. Raw string literals made multiple text so much cleaner. Here's an example. Here you have no escapes, no new lines, just the text. Simply put your text into 3 quotes and that's it. It will work. However, here's an even better twist. They support interpolation too. Just put the dollar symbol in front and you can use the curly braces to embed variables. It even works with nested braces and multiple lines, perfect for generating SQL, code, or JSON templates. Need a literal curly brace or dollar sign? Just add more quotes. It can go on forever. 103. Using required properties in C#, they're great for enforcing object initialization. However, if you write a custom constructor, they act a bit weird. You might still get a warning saying required members must be set, blah blah blah, even though you clearly said it. To fix it, simply add this. You can use the sets required members attribute on the constructor itself, and this tells the compiler, yes, this constructor handles required members, so chill. This is useful in factory methods, deserialization, or even legacy compatible APIs. 104. Love the init keyword but stuck on an older .NET version? Well, you try to compile something like this, and the compiler says, well, what is init? Here's the trick. Add this little type manually to your project. That's the missing piece. C# 9 needs isExternal init at compile time, but it doesn't exist in all the runtimes. Adding this lets you use init properties in .NET Standard 2.0, .NET Framework, as well as shared libraries targeting multiple TFMs. Note that this is compiled only and no runtime behavior changes. 105. In C# 12, you can write this. That's a collection expression, and it works for more than just arrays. However, do you want to use this syntax for your own type? Add this attribute. By adding the collection builder, C# knows how to build your type from a collection expression. Your builder just needs a static method, just like this one, and boom, you can now write this. It's clean, expressive, and fully type-safe. 106. Imagine you have user.setActive and then true. This looks innocent enough. However, what does true actually mean? Is it enabling? Is it overriding? Sending a welcome email? Boolean parameters are a code smell. They hide meaning and force you to guess. Instead, name the intent. Write separate methods, user.activate or user.deactivate. This is a very simple example, but the code becomes self-documented and you usually don't need comments. 107. Need a delay in your code? Never use thread.sleep. That blocks the entire thread. Nothing else can run, no IO, no events, no tasks. In modern .NET, you should use this instead, await task.delay. Task.delay is non-blocking. It lets the thread go and do other work and later come back. Even in console applications or services, blocking threads do harm scalability. So when is thread.sleep okay? Well, maybe testing some race condition or in real edge case scenarios where you try to simulate something slow. But for real code, thread.sleep is almost always a red flag. 108. Here's a weird one. Imagine you have A as null and B as a string, and then you try to add the two strings. What happens? A null reference exception? Nope. This will print normally. The problem is you won't see the null because it will be an empty string. In C#, string concatenation is null safe. If any parameter is null, it is just treated as an empty string. Why? Because of how the code is built under the hood when you're using string concatenation. But be careful, just because it works doesn't mean it's what you meant. 109. Think interfaces are just for instance members? Not anymore. In C# 11, interfaces can declare static abstract methods. Why? So generic code can call static methods on the type parameter. This unblocks many patterns such as generic math, parsing, as well as factory methods. You can also add static virtual members with default implementations. 110. In C# 13, you can finally access the backing field of an auto property without declaring it yourself with the field keyword. It points directly to the compiler-generated backing field. And why does this matter so much? Because you can now customize logic without rewriting the entire property. No more this, for example. Just use field, clean, safe, and built-in. 111. By default, your C# class is open for inheritance. But ask yourself, do you actually want someone to subclass it? Probably not, unless you're doing something very specific. If not, mark it as sealed. Why? Because inheritance brings complexity. It forces you to worry about base behavior, overrides, and breaking changes. Also, the JIT can optimize sealed classes better, giving you some nice performance. That way, method calls can be devirtualized. And if you ever need inheritance later, just remove sealed. If you're using it as part of a library and sealed exists, sealed is there for a reason and you have to respect it. 112. Writing a link like this, well, that works, but there's a cleaner option. It's called method groups. Instead of doing this, you can do this, and you remove the entire parameter. Same result, less noise. No extra variable names and no arrow syntax. Even better, method groups can be faster. The compiler skips creating a delegate wrapper in some cases. And you're not limiting link, any method with a function like this will work. 113. Let's create a new empty list. You add 5 items, now list.count is 5. But what's the list capacitive? It might be 8, 16, or even more. Count is how many items are actually in the list. Capacity is how much space is reserved behind the scenes. And every time the list outgrows its capacity, C# resizes the backing array, and that's quite expensive. So what should you do? If you know roughly how many items you need, set it up at front in the constructor. This will avoid multiple resizes and extra allocations. 114. Are you logging like this with string interpolation? Well, this looks clean, but it's not actually cheap, and you're losing context. That interpolated string gets allocated even if logging is disabled. Here's a better way. First pass the string as a template and then pass the parameters. That's called structure logging. No allocations, no formatting costs unless your code actually runs, and your logs stay queryable in tools like Seek, Kibana, or Application Insights. 115. Need to load data during object construction, but the code you have to call is async? You might be tempted to do something like this with getAwaiter, getResult, or just .result. It looks fine until you hit production. Calling .result or .wait on an async method blocks the thread and risks deadlocks, especially in UI apps. Why? Because the async method might need to resume on the same context, which is now blocked by the constructor. Better, move the async work out of the constructor entirely and create an asynchronous factory method. 116. Still doing this in multi-threaded code where you have a dictionary and you're locking it? It works, but it's manual, error-prone, and can hurt performance under contention. Here's the better way. Just use a concurrent dictionary. Concurrent dictionary is built for concurrency. No need to lock, it handles thread safety internally. It also gives you atomic methods like get or add or update, and try remove. Way cleaner, way faster. 117. Using a dictionary in C# like this, where you just say new dictionary, if you're adding a ton of items, that line could be costing you performance. Why? Every time the dictionary grows beyond its capacity, it resizes and rehashes, which is pretty expensive performance-wise. Solution? Pre-size it. You can pass the size at the constructor. Now it allocates once and avoids the slow resizing process during inserts. So 118. Capacity is how much memory a collection has allocated. Let's say you have a new list and you pass 1000 as the constructor parameter. It prevents resizing during inserts, which is great for performance. But what if you're done adding items? Your list has 10 items but still holds 1000 slots. That's a memory waste. Enter trim excess. You can do list.trimExcess to shrink the list's internal array to match the actual number of items. So use capacity to scale up efficiently and use trim excess to scale down and free memory. 119. Checking if a string is empty. Most devs write something like this, string.isNull or empty. But here's the catch. That still lets empty string, like a white space, pass through. A better option? String.isNull or whitespace. It catches null, empty string, and even whitespace, because whitespace usually isn't a valid input either. Imagine things like form validation, user inputs, required fields, or config values. However, if an empty string is a valid parameter in your use case, use string.isNull or empty. 120. In C#, default isn't just one thing. It behaves very differently for classes and for structs. For classes, default will just be null. Nothing is constructed. No memory, no fields, no new. For structs, it creates a zeroed out instance, every field set to its default value. No constructor is called, but memory is allocated on the stack. Why it matters? With structs, default gives you a valid but empty value. With classes, default gives you null, which might break stuff. 121. This property with the getter and setter looks harmless, but now any code can set name from the outside, even if they shouldn't. Better, make the setter private or protected. Or if you only want to set it once upon initialization, use init. Now that's only settable during object creation, perfect for immutability. Why it matters? Because it protects internal state, prevents accidental changes, and makes your API safer and clearer. 122. Want to swap two values in C#? You can do it without temporary variable. Simply do this. Yep, that's tuple deconstruction. And yes, it works anywhere, even in constructors. For example, let's say you want to ensure min is always less than max. You can do it like this, without any temporary value. It works with any two variables of the same type and respects value semantics. 123. Using cancellation token source in C#, well, it works great for cancelling async work, but here what most developers miss. You need to dispose it. Seriously. Why? Because cancellation token source can create timers under the hood, especially when you're using timeouts. That spins up a timer, and if you've forgotten to call dispose, it sticks around holding memory in a thread longer than needed. 124. Checking a type and a condition? You don't need any of that nesting. C# lets you combine both in one line like this, where you say something is of that type, and then you can get a variable of that exported type and use its properties to do a check in the same condition. This also works in switch expressions too for clean and expressive pattern matching. 125. Trying to benchmark like this by getting a delta based on the date time? Well, it looks simple, but it's not accurate. Datetime now or UTC now isn't high resolution, and it can jump if the system clock changes. Use this instead. Get the stopwatch.timestamp value in the beginning of the work, and then calculate the elapsed time using the getElapsedTime method of the stopwatch. This allows for high precision, reliable timing with just 2 lines. This approach is also recommended over .start and .stop on the stopwatch to keep it clean and static. 126. If you're logging like this and you have a line of logger.log debug, what do you think happens when you deploy to production and your minimum log level is information warning? Well, this line is still there and it's not really logging anything, but it's still allocating, formatting, and being called. That's all wasted. Better, guard your logging like this using the logger.isEnabled and passing down the log level. Even better, if you use source-generated logging like this check will be automatically added for you, so you no longer have unnecessary string building. 127. Trying to speed up your loop by using parallel.for? Careful, that might actually be slower, not faster. Parallel.for creates multiple threads, but if your work is tiny, the thread switching overhead can outweigh the actual work. You're spending more time scheduling than doing anything else useful. What should you do? Benchmark both parallel.for and a plain loop and see the difference. The fastest one wins. 128. Need a timestamp? Most developers reach out for this. Datetime.utc now. It works, but in high frequency code, it's slower than you think. Datetime.utc now calls into the OS. This means a system call every time, and those aren't cheap. If you're calling this in a tight loop, logging pipeline, or real-time processor, you're adding hidden overhead. Better? Just use stopwatch.getTimestamp. 129. Ever wonder what a closure is in C#? It's when a lambda or local function captures variables from the outer scope and keeps them alive even after the method exits. Here's an example. That lambda uses count, a local variable, but it still works even after the method finishes. Why? Because the compiler creates a hidden class to store the captured variables, and that's the closure. But be careful, close can lead to unexpected memory allocations and even memory leaks if you keep them around for too long. 130. Need a unique ID? Most developers do this, they just call GUID.newGUID. It works, but if you're in a hot loop, newGUID isn't as cheap as you think. newGUID hits the OS to generate randomness, which is a system call, and adds latency per iteration. Thousands of IDs, meaning thousands of potentially expensive calls in the context of generating an ID anyway. Consider using something like ULIDs or sequential IDs when you don't need full cryptographic uniqueness. 131. Ever needed to branch logic based on multiple values in C#? You don't need nested if statements. Instead, use tuple pattern matching in a switch. It's clean, readable, and handles multiple dimensions at once. The underscore matches anything. You can use constants, guards, or even types inside the tuple. 132. If you're using Entity Framework code to load data but don't plan on updating it, here's one method you should always consider. As node tracking tells EF, hey, I'm reading this, but don't track the changes. Why does it matter? Tracking adds overhead. EF stores snapshots, watches properties, and burns memory for basically nothing. Use it in read-heavy applications, reports, queries in loops, or anywhere you don't want to call save changes async at the end. 133. Logging or saving timestamps? Whatever you do, don't use datetime.now. Datetime now gives you local time based on the server's time zone. In today's cloud computing environment, you never really know where that server might be, so that date might be miles off. In order to make sure your times are consistent, use datetime.utc now. UTC is universal and it doesn't care about time zones, daylight saving, or server location. 134. Yes, the Entity Framework Core now lets you write raw SQL using the from SQL raw method. But here's what most people miss. EF still tracks these results like any other query as if it was written with LINQ. This means memory overhead, change tracking, and snapshotting even if you're just reading. Want it linear? Use as-node tracking like this. Now EF skips all the tracking, perfect for reporting or read-only queries. 135. Fetching full EF core entities when you only need a few fields, that's wasting memory and making your queries much slower. In EF core, you can project directly into DTOs like this. No tracking, no navigation properties, just what you need to expose to your users. This avoids pulling entire objects, especially useful when your entities have relationships or lazy load collections. And it works with anonymous types too for quick views or grid data. 136. Need to update or delete rows in bulk in EF Core, but you don't want to load entities into memory? From EF Core 8 onwards, you can use the execute delete or execute update methods just like this. There is no entity tracking here, so EF Core sends a direct update or delete to the database, which is very fast and lightweight. When you don't need the full EF Core logic and you just want to make these operations against your database, use these methods to boost performance. 137. When your database call fails, what do? You might have a catch-all approach like this, but that's quite risky. Not all exceptions are the same and should be treated the same. Some are transient, some are timeouts, deadlocks, connection drops, and so on, and some can be retried. Others are fatal, wrong schema, auth failures, constraint violations, and so on. You should be using exception filters or libraries like Poly to automatically fail or retry exceptions that can be retried. 138. Every time your app creates a DB context, it allocates memory, builds internal state, and opens the connection. But you can actually avoid all that with DB context pooling. Instead of having the add DB context call, say add DB context pool. That way, the framework reuses the DB context instances behind the scenes. This leads to less memory pressure, fewer connections, and faster call starts. But there are downsides. Don't use this if DB context stores scoped state like injected services. If your DB context is stateless, pull it. 139. If you're running the same EF Core query hundreds or thousands of times in a short period of time, there's a hidden cost, query compilation. Each LINQ query gets translated into SQL, and that translation has overhead. The fix? Use compiled queries like this. Then simply call this, and you automatically have faster query execution, less CPU usage in hold paths, and fewer allocations. However, compiled queries don't help in every situation, so please benchmark your own use case. 140. Using includes to load related data in EF Core, careful, it might blow up. When you chain multiple includes, EF tries to fetch everything in one big join. Sounds efficient, but it's not always. It can produce a massive join and return duplicate records for every related entity. The fix? Just add as split query. EF Core will now run separate queries for each include, leading to less data duplication and less SQL madness. 141. Trying to choose between Dapper and EF Core? Well, here's the real answer. You don't have to pick one. Use Dapper when you need fast and lightweight reads. For example, something like this is minimal, fast, and maps straight to the DTO. But you can also use on top of that EF Core when you need navigation properties, change tracking, migrations, and business logic baked into your entity model. 142. Writing raw SQL and you want to prevent SQL injection? Well, here's how you can do it with Dapper. Take this query for example. You have this new ID equals 5 anonymous type, which is exactly how Dapper will bind the parameters under the hood to that query. Dapper builds parameterized queries, not string concatenation. But if you do something like this, then you're creating a vulnerability because of course you can inject any string in here, even with Dapper. 143. By default, EF Core assumes your primary keys are generated by the database, like auto-incremented IDs. But what if you want to set that ID manually? Well, here's how you can take control. You can use the value generated never parameter for that property. This tells EF, don't expect the database to generate this, I've got it. Why it matters? Because without this, EF might ignore your IDs or throw an insert. It's perfect for scenarios like importing existing data, using external GUIDs, or composite keys from outside sources. 144. If your API mostly reads from the database, you might be tracking changes you'll never use. By default, EF Core tracks every entity it loads. That means snapshotting, change detection, and more memory. But if you're not updating the data, skip the tracking. You can make as no tracking the default by using the use query tracking behavior no tracking when you register the DB context. Now,
All queries are lightweight by default, and no as-no tracking is needed on every line. 145. Looping over a list and saving each item like this? Stop. This creates a new database transaction every time on every iteration. This results to more round trips, slower performance, and increased log contention. The fix? Add everything first and then save all at once. Now EF batches the inserts and uses a single transaction. If you need more fine-grained control, you can use save changes in chunks, but not do it per row. 146. Think secure string makes your secrets bulletproof? Well, not quite. Secure string was designed to protect sensitive text like passwords in memory. However, there's many catches. It's still stored in memory, meaning that eventually it has to be used, and that means that it will be converted usually back to string anyway. This still makes it vulnerable to things like memory dumping, so it isn't really securing anything. Don't use it. 147. Need to join two tables and map the result to two objects in Dapper? You can with split on. Here's an example of a query using a join. Now map it like this. That split on ID tells Dapper start mapping the second object at the second ID column. Why it matters? You can now join and hydrate multiple objects without having to write tons of manual mapping code. 148. So, Dapper by default lets you do something like this, where you just query and you have no model, no type, just raw results as dynamic. It's fast to write and great for prototypes, but it's dangerous in real apps, like every use of dynamic. You lose IntelliSense, compile time safety, and easy refactoring. Misspelling a column? You won't know until runtime. The fix? Simply use strongly typed models. 149. You add a method to an interface and then suddenly every class implementing that interface breaks, which is quite annoying. Default interface methods fix that. You can put a fallback implementation in the interface itself now. Existing classes? Well, they keep working. New classes, they can override it if they need to. It's not for your day-to-day CRUD applications, it's more for library and framework authors who need to evolve APIs without breaking everything. That's the main use case. Default interface methods guarantee backwards compatibility without the pain. 150. Here's an interesting gotcha. Think constructor logic runs first in a class? Well, not in C#. Fields are assigned before the constructor's body even starts. Here's an example. The output here will be first field initializer and then constructor body. Why it matters? If your field depends on constructor parameters, you're already too late. The fix? Use the constructor itself to assign complex values, not field initializers. 151. Need to run some setup code before even main itself? You don't need static constructors or weird hacks. Just use this, the module initializer. Yes, even before main starts, this will be triggered. When is this useful? Well, global login setup, runtime feature flags, diagnostics, or one-time init across the app. Rules, it must be static, it must return void, and it can take parameters. 152. Are C# nullable warnings too noisy in some places but too quiet in others? Well, good news, you can turn nullability on and off per section on your file. For example, here's nullable enable and here's nullable disable. Why would you do this? Well, maybe you're dealing with legacy code, auto-generated files, or third-party APIs, and you don't want the noise. As a bonus, you can even scope it inside the method itself like this. 153. Still checking you're running OS with custom hacks like the isOS platform call? Well, that works, but there's a simpler way. In .NET 5 and forward, we got new operating system methods like isWindows, isLinux, or isMacOS. It's built-in, readable, and cross-platform safe. Need version info too? Just use the environment.os version and use a version string. Just don't write your own OS detector, you'll get it wrong. 154. Need to create a temporary file in C#? Don't do this with the path of the temp folder or this just trying to get an absolute path. These paths are hard-coded, OS-specific, and brittle. The fix? Use the path.getTemp file name method. C# picks the right temp folder for your current OS, whether it's Windows, Linux, or macOS. As a bonus, the file is created immediately and it's guaranteed to be unique. If you just need a name, use path.getTempPath. After that, you can append your own file name. 155. Think user secrets are only for ASP.NET? They're not. You can use them in any .NET app, console, desktop, and even background workers. Just do this. Add this NuGet package called Microsoft.extensions.configuration.usersecrets and add this to your builder. Add user secrets. And that's it. Secrets are now loaded from your dev profile. Why use them? Because you can keep your API keys out of source control, you don't need any .env files,
and you can have them as per developer, per machine. 156. Ever build your app twice and get two different binaries even if nothing changed? That's because your builds aren't deterministic. The fix? You can add deterministic as true on your CS proj. Now every build with the same inputs creates identical outputs, byte for byte. Why it matters? Because you get consistent binaries, easier debugging, better caching, and verifiable releases. It's especially useful in CI pipelines, build servers, and OSS projects where trust and repeatability matters. 157. Want your builds to be clean, consistent, and CI ready? Then add this to your CS proj. Continuous integration build equals to true. What does this do? It strips out local dev junk like uncommitted git info, debug file paths, and machine-specific artifacts, and it's perfect for CI and CD pipelines, reproducible builds, and verified NuGet packages. As a bonus, if you're using source length, this ensures only committed files make it into the PDBs. 158. Ever check if one type can be assigned to another? You've probably written this, is assignable from, but it reads backwards. You're asking, can the base type be assigned from the derived? Not very intuitive.
Incomprehensible to me.
In dotnet 7 and later, you can use this instead, is assignable to. Now it reads naturally. Can this type be assigned to that one? Exactly what you're thinking. 159. Tired of repeating the same settings in every CS proj? Target frameworks, nullable, analyzers, and just copy-paste overload? There's a better way. Create a file called directory.build.props at the solution root. You can put whatever you want to be global for all of your projects there, and that's it. Every project below it will inherit these settings automatically. Why it's amazing? Because there's no duplication, it's easy to update, and keeps projects consistent. You can even add it on your template, so every time you create a new project, they all share the same settings. 160. Think assembly.getExecutingAssembly and getEntryAssembly do the same thing? Well, they don't. Assembly.getExecutingAssembly returns the assembly where the code is running, even if it is in a shared library or a plugin. But assembly.getEntryAssembly returns the assembly that started the application, like your main.exe project. Why and where it matters? In shared libraries, use getExecutingAssembly to find yourself. In host apps, use getEntryAssembly to find the root. And just a heads up, getEntryAssembly can return null, especially in unit tests or on managed hosts. 161. Ever need two versions of the same NuGet package in one project? Normally that's not allowed. You'll get binding conflicts and ambiguous references. But here's a trick. You can use extern alias. First, go on your CS proj and add a reference to one of the libraries using the reference, include, and then hint path and aliases. Then, at the top of your CS file, add extern alias and whatever name you gave to your alias in the CS proj. Now you can use both versions side by side like this. Just make sure you don't abuse it because it can actually get a bit confusing and dangerous. 162. Still using console.writeline to debug your unit tests? In next unit, that won't work. Console output gets swallowed. The right way? Use this. Inject the itest output helper and just use the writeline method. It works with fact, theory, and anything else that can log something inside the test. 163. Building file paths with plus or string interpolation? Well, that looks fine until you deploy to Windows, Linux, or Mac. Now you'll get broken slashes or double separators. The fix? Use path.combine. It works on all OSs and it always uses the right slash for that OS. It also removes extra slashes automatically. 164. Want zero garbage collection during a performance critical block of code? You can request that using the gc.try_start_node_gc region, and you can allocate some space for it. This tells the runtime, don't trigger GC until I'm done. It's perfect for real-time systems, short, tight loops, high-frequency trading, audio, and game engines. But be warned, if the GC has to collect during that region, your app throws yes at runtime. And you need to call GC and no GC region or the runtime gets grumpy. 165. Need JSON web tokens for testing a secured API? Skip the full identity setup and use this quicker way. Just run .NET user-jot create. And that's it. You get a local jot you can use right away with no login, no UI, and no database. Want to add claims? Just add the claim parameter and set the role to whatever you want or any other claim. And it automatically integrates with authentication.add JSON web token bearer. Where it works best is local development, API testing, Swagger with auth, and role-based endpoints. 166. Publishing NuGet packages, make them easy to debug. Do not run .NET pack. You'll get the DLL but no symbols, no source links, and no debug context. Do this instead. In your CS proj, add include symbols, include source, publish repository URL, and embed untracked sources. And don't forget to add the source link NuGet package. The result? Step into your package code, see your actual source code, and there is no symbol server needed. 167. Tired of code reviews nitpicking tabs, spaces, or missing brackets? Don't argue about style. Automate it. Run this command instead. .NET format. It instantly fixes indentation, new lines, braces, unused usings, and more. It works on entire solutions or just one file. You can even add it to pre-commit hooks or CI. You can also add an editor config file to define your team's rules, and .NET format will follow them. 168. Still copying gitignore files from random GitHub repos? Well, stop. Just run .NET new gitignore. It gives you a ready-to-go gitignore tailored for .NET. It ignores bin, object, .vs, handles writer, VS Code, temporary files, and even supports Unity and more. It's up to date, maintained by Microsoft, and saves you from committing junk. 169. Ever seen this on an enum, where you can have the flags attribute and then weirdly the values of the enum are powers of 2? Well, this tells the compiler these values can be combined using bitwise operations. So now you can do something like this, where you can have permissions for read and write separated by a logical OR, and check it like this using the hasFlag method. Without flags, you'd still be able to combine them, but the toString output and hasFlag behavior won't make sense. So use flags when your enum represents a set of options and not just one state. 170. You've probably heard of the advice saying, reuse the HTTP client, don't create a new one per request. So you make it static, and that sort of fixes the problem, but not quite. Static HTTP client lives forever, which means it never refreshes DNS. If the server's IP changes, your app could keep sending requests to a dead address. And if you're setting headers per request, well, a shared client can lead to thread safety issues. A better option? Just use the iHTTP client factory, which you can register using the add-HTTP client method. It handles reuse, DNS updates, and lifetime management. 171. Writing a .NET console application that runs in scripts or CI? Don't just print success or failed. Communicate it properly. Use this instead. Environment.exitCode equals whatever you want it to be. This sets the process exit code, just like in native apps or shell scripts. In PowerShell or Bash, you can check them like this. And in CI pipelines, non-zero exit codes means fail the job. As a pro tip, use 0 for success and any non-zero value for failure. It's a standard and don't break it. 172. Working on a .NET project and you're not sure if your dependencies are up to date? Don't waste your time manually checking NuGet versions. Use this instead. .NET list package --outdated. This scans your project and shows you which packages are stale, including current, wanted, and latest versions. It works across solutions and projects, so you can spot problem dependencies in seconds. I recommend running it regularly to avoid security issues and painful upgrade surprises. 173. Ever post your .NET application in debug mode and seen objects filled with useless info? Don't dig through properties every time. Make them show what matters. Use debugger display and then pass down a user name and age like this, and now when you hover or inspect this object, you will see user is Nick and age is 32, instead of a class name that normally means nothing. You can also reference any property or even private fields inside the string. 174. Did you know you can turn a list of t into a span of t without copying anything? Normally, if you do list.toArray and use that as a span, you create a new array, which means extra memory and extra allocations. But with collectionsmarshal.asSpan, you get direct access to the list's underlying array. Now you can work with the data in place extremely fast and without any copying. Be careful, however, it is unsafe. If the list grows or shrinks, your span can be invalidated. 175. Need a fast producer-consumer queue in memory in .NET? Forget blocking collection. Use channel of T instead. It is async, built-in, and faster. First, create a channel with options like this with channel.createBounded, and this gives you a bounded queue with back pressure. Next, a producer writes items in it asynchronously with the writer.writeAsync method. and a consumer reads them with async streams using the reader.readAllAsync. On a basic level, that's it. No locks, no polling, and it's just a clean async pipeline. However, this is just the basics. Use bounded channel options to tune capacity and performance for your specific workload. 176. Need to collect results from multiple threads without locks? Don't use a regular list of T. It's not thread safe. Use this instead, a concurrent bag of T. Each thread can safely add items into the bag at the same time, and you can pull them out using the try-take method. It's unordered, perfect when you just need to collect data fast, but if you need a FIFO first in, first out ordering instead, you should use the concurrent queue. Concurrent bag just gives you lock-free performance for parallel producers. 177. Not every enum needs a flags attribute, and misusing it leads to confusing bugs. Flags tells the compiler these enum values can be combined with bitwise OR. So by adding it like this, you can do something like this. But here's the mistake. Don't add flags if your values aren't powers of 2, or if you never actually combine them. ToString becomes noisy, has flags becomes weird, and your logic gets harder to debug. Subscribe for more .NET tips. 178. Need to update the dictionary conditionally in .NET without extra lookups? Instead of dict.tryGetValue plus assignment, use this hidden gem. collectionsmarshal.getValueRef or add default. This gives you a ref directly to the value slot in the dictionary. If the key exists, you can mutate it in place. If it doesn't, you can initialize it. This means no double lookups, no copying, and just direct reference access. However, keep in mind this is unsafe if the dictionary resizes, so only use it while holding onto that ref briefly. 179. Still writing your own get hash code by hand? You don't need to juggle primes or XORs anymore. .NET has a built-in helper. It's the hashcode.combine method. This combines multiple fields into a high-quality hash, consistent and fast. Need more than 2? It supports up to 8 values directly. For bigger objects, chain it with the hashcode.add method. 180. Ever wonder why .NET apps start fast and run fast? It's thanks to tiered JIT optimization. At first, the JIT, or the just-in-time compiler, does a quick compile. That's the tier 0 compile, which is fast with minimal optimizations. This will let your app start almost instantly. But as methods run more often, the JIT recompiles them, and that is tier 1 optimization, heavily optimized for hot paths. This means your code gets smarter and faster the more it runs. You can also control it with this runtime config, tiered compilation true or false. 181. Want to squeeze more memory out of your hot paths in .NET? You can tell the JIT to go all in on optimizations. Just add this attribute, method_impl, and set the value to aggressive optimization. This has to be for critical code only, and it hints the runtime that spend extra time optimizing this method even in release builds. It's different from aggressive inlining. This one tunes the JIT's choices, not just inlining. However, only use this in methods that run a lot. There can be issues and diminishing returns if you do it elsewhere. 182. Are you building strings in loops like this? Here's the problem. Every time you use the plus equals operator on a string, .NET creates a completely new string in memory. Strings are immutable in .NET, so they can't be modified in place. This means in a loop with 1,000 items, you're creating 1,000 separate string objects. The solution? Use String Builder instead. String Builder is designed for this exact scenario. It maintains an internal buffer that grows as needed, so you're not constantly creating new objects. The more items you have, the bigger the performance gain. 183. Do you find yourself writing null checks like this? There's a much cleaner way to do this in C#. Meet the null coalescing assignment operator. This is how it works. This single line does exactly the same thing. It checks if the cache is null, and only if it is, it assigns the new value. If cache already has a value, then nothing happens. It works with any type, and the beauty of this operator is that it makes your code more concise and easier to read. 184. Have you ever needed to check if a collection is empty before processing it? Here's the problem. When you call count on an IEnumerable, Link has to iterate through the entire collection to count the items. If you're working with a large dataset or an expensive query, this can be very costly. Now here's the trick. If the IEnumerable is actually a list, array, or collection underneath, we already know the count without iterating, but count doesn't check for that. Enter try get non-enumerated count. This method checks if the count is available already without enumerating the entire collection. 185. Are you creating temporary arrays like this? Every time this method runs, you're allocating a new array on the heap. If this happens frequently, you're putting pressure on the garbage collector. Instead of doing that, use an array pool like this. Array pool maintains a pool of reusable arrays. When you rent an array, you get one from the pool, and then you return it. and when you return it, it goes back for reuse. No new allocations, no garbage collection. Now, the rented array might be larger than the one you requested, so always use the size you asked for, not the array length. Also, make sure you're always returning in the final block to ensure that it gets back to the pool. 186. Using async methods in high-frequency code paths like caching, where you might have something in the cache in memory, or you might want to go to the database. Every time you return a task, you're allocating an object array on the heap. In high-throughput scenarios, that's a lot of allocations. Instead of using task, use value task instead. Value task is a struct that can represent either a completed result or an actual task. When your method completes synchronously, like a cache hit, there's zero allocation. Only when you actually need to await does it allocate. Just remember, value task can only be awaited once. Don't store it in a variable and then await it multiple times. Use it and then move on. 187. Passing arrays or chunks of data between methods. Managing offsets and lengths manually is error-prone. One mistake and you're accessing the wrong data and throwing an exception. Use memory of T instead. Memory of T represents a contiguous region of memory. It encapsulates the array, offset, and length in one type. Safer and cleaner. Use read-only memory of T when you don't need to modify that block of memory. Memory types work with span for high-performance scenarios. This is perfect for parsing buffers, working with network data, or any other scenario where you're slicing arrays. No copying, just efficient views into existing memory. 188. Do you check if a collection has items and then you process them? This looks innocent, but here's a hidden problem with this approach. You're enumerating the collection twice, once in any and again in the for each loop. If user comes from a link query or a database call, you're executing the query twice. The solution? Materialize the collection. Now the query executes once, the results are stored in memory, and you can safely iterate items multiple times. The trade-off is memory usage, but usually better than running expensive operations multiple times. 189. Storing just a date or just a time in C#, while using the date-time object for these is confusing. You have to ignore the time component for dates and create arbitrary dates for times. Use date only and time only instead. Date only represents just a date with no time component, while time only represents just a time with no date component. Your intent is crystal clear. You can even convert them from and to date time if needed, but keeping them separate prevents confusion and makes your code more maintainable. 190. Need to process items in batches? This works, but it's verbose and error-prone. You're managing indices, and skip creates overhead for each batch. Use chunk instead. Chunk splits your collection into arrays of a specified size. The last chunk might be smaller if there aren't enough items remaining, but this way you're processing in a clean, readable, and efficient way. This is perfect for batch API calls, database inserts, or any other scenario where you need to process large collections in smaller groups. 191. Need to find the item with the minimum or maximum value in a collection? Something like this works, but you're sorting the entire collection just to get one item. That's unnecessary work. Use min by or max by instead. Min by and max by scan through the collection once, keeping track of the best match. No sorting required. It's faster and more memory efficient. This makes a massive difference with large collections because instead of sorting all the items, you just iterate through them once. 192. Converting a list to a dictionary? Using the toDictionary method looks simple, but if you have duplicate IDs, it will throw an exception. You have options depending on what you need. If you want the first occurrence, then you can use group by that ID and then toString with the key and then call the first method on the value. If you want the last occurrence, use a different approach. Loop around the users and then just set the value. This will override any duplicates. Or if you need all the items with the same key, just use group by. By doing that, you can use group by ID, key, and then toList for the values, keeping all the data. The key is to understand exactly what you need that method to do. 193. Splitting strings and trimming white spaces. Something like this with a split method works, but you're iterating through the array twice, once for split and once for trimming. Instead of doing that, use string split options trim entries. The split method trims each entry automatically during the split operation. One pass, cleaner code, and better performance. You can also combine it with the remove empty entries, and now you're trimming white space and removing empty entries in one operation. No link needed and no extra allocations. 194. Handling multiple async operations that fail. When tasks throw exceptions, you get nested aggregate exceptions, and exceptions inside exception, and then handling becomes very, very messy. You can use flatten to simplify this. Flatten recursively unwraps all nested aggregate exceptions and gives you a single flat list of all the actual exceptions. No more nested loops or recursion. This is especially useful when you're doing complex async things using the task.whenall. 195. Need to resolve multiple implementations of the same interface using the built-in DI container? Well, the problem is the built-in DI container only resolves the last Rails implementation. You need a factory partner to get both. You can, however, use keyed services instead. You can now have something like this, and you can resolve them through the constructor or the method like this. This is perfect for strategy patterns, multi-tenant scenarios, or anywhere else where you might need several implementations. 196. Getting nullable reference warnings everywhere? The null forgiving operator tells the compiler, trust me, this isn't null. But if you're wrong, you get a runtime null reference exception. If you know it's not null, prove it to the compiler. Now the compiler understands the null check, and the callers know that this method never returns null. It either returns a user or it throws. Sometimes you genuinely know something can't be null due to external logic. You can suppress it by using the exclamation mark, which is an acceptable use in this use case. However, you should treat the bang operator as a code smell. Ask yourself, can I restructure this code to avoid it? 197. Creating and disposing expensive objects repeatedly? Well, if that method runs thousands of times, you're creating and destroying objects constantly. That's wasteful. Instead, use an object pool. Using an object pool, you maintain a collection of reusable objects, and you get one when you need it, and you return it when you're done. The pool handles creation and reuse. You can even configure it in your DI container like this. This works great with the string builder, HTTP client handlers, byte arrays, or any expensive object you use frequently. Just remember to reset the object state before returning it to the pool. 198. Confused about which options interface to use? Let's break it down. iOptions is a singleton. It reads configuration once on startup and never updates again. If your config changes, you won't see it. iOptions snapshot is used for scope reloading. It will reload configuration once per HTTP request, which means that each HTTP request gets fresh config values, perfect for settings that change occasionally. iOptions monitor is used for real-time changes. It is a singleton that detects config changes immediately and notifies listeners. Use this for background services or singletons that need live updates. 199. Processing items by priority using a sorted list like this? Sorting the entire list every time you add or remove an item is expensive. That's O of n log n for every operation. Use priority queue instead like this. Now priority queue keeps items ordered internally using a heap. And Q and DQ are both O of log n, much faster for large collections. This is perfect for task schedulers, event processing, pathfinding algorithms, or anywhere you need the highest priority item next without sorting everything. 200. Need to access private members for testing? Well, don't do that. Literally, it's a bad thing. It's a bad idea. But if you need to, do not use reflection. Reflection works, but it's slow and has no compile time safety. If you just rename that field, your code will silently break. Unsafe accessor is faster, but let's be honest, it's also a bit cursed, which I like. You can use it like this, and now you can access the item directly like this. No reflection overhead, it's compiled directly to field access. But should you actually use this? Probably not in production code unless you really know what you're doing, and even then, there should be a way around what you're trying to do. But it's good to know that it is there if it's your last resort. It's much better than reflection. Subscribe for more .NET tips.